research methods 6. Firstly, descriptive statistics can be split into two parts, which are measures of dispersion and measures of central tendency. Each terminology can be broken down further, such as the measures of dispersion can be found by using standard deviation and the range, whereas measures of central tendency can be found by doing the mean, median and mode. Using a quick definition to show you what the measurements mean. So firstly, standard deviation is the range around the mean. Next, the range is the difference between the difference between the highest and the lowest number. Moving on, mean is the average of the data you are sorting. Median shows the middle value of the data set, and finally, mode is the most common value in the data set. So next we're going to the distribution curve. So this explains how people expect data to look when it's on a graph. The main purpose of the curve is to show a normal distribution. Where the peak is on the curve is the mode, and the data should be distributed equally from the central value. If you were to look at the graph and split it into different parts, it will relate to different percentages of the standard deviation, such as the middle of the graph's one standard deviation equals to 68%. When then looking going outwards, 2 standard deviation is 95%, and finally the last bit of the graph will be 3 standard deviation, which is 99%. Next is skewedness. So this conveys where the peak is of the curve. There are different outcomes of the skewedness, therefore there are different graphs which will show this. The left-hand side graph will show a negative distribution. The peak of the graph is on the right-hand side, therefore it's a higher distribution. The middle graph shows an equal distribution, and then the right-hand graph shows the positive distribution. There is the peak, therefore the peak is on the left-hand side of the graph. Next, so this graph will show you how flat or steep the curve is. This is the same as skewedness. So there's 3 types of graphs there, which will show different outcomes. So obviously the positive one is the steepest line, equal one is the middle curve there, and lastly the flat curve is the negative one. Inferential statistics is a way to test either relationship or differences in data which have been collected. When the test is completed, they will use the results and to see if there was a relationship or a difference, and it will come down. It will show relational differences and that it didn't come down to chance. In sports science, they will use 5% as the accepted level of chance. The significant level is P is smaller or equal to 0.05%. Therefore, if your result comes higher than the 5%, you've either gone wrong somewhere or it's due to chance. So parametric and non-parametric. There's 2 types of tests which will be used in inferential, and it's either parametric or non-parametric. But this depends on what data you'll be using. So if you were to use parametric data, it will be used for interval and ratio data. So interval data is based around the scale, and that has equivalent intervals of measurement with equivalent intervals between each score. The ratio data that we talked about has a proportional equal unit of measurement. It will range from 0 upwards and cannot be a negative score. So if you were to use your non-parametric, you would use normative and ordinal data. Normative is data is putting participants into categories and then counting. Whereas ordinal data is when you use data in order which has no indication of skill difference. So such as in a player in tennis can be ranked first, second, third. We won't know how much better the first player is than the second player because they're just ranked. So this table shows the different tests which can be carried out to show what the tests are for, which is either showing the relationship or the differences. And the type of test again, which is either parametric or non-parametric. So we're looking at the t-test. It can be either done. So t-test there is obviously testing for differences in parametric, but it can then be broken down into more further. So when you use t-test, you have to look at it if it's done independently or dependently. So when doing the dependent test, you will be using the same group and then doing the same thing twice, whereas independent testing is using different groups or the same group doing a different thing. So we're going to go on to Edexcel in a minute. I'm going to show you the data what I've collected. So I'm just going to explain the experiment. So the experiment what I was doing to see if there was a relationship between the shoe size and standing long jump. For this, we had to use the Pearson product movement correlation coefficient test. I'll explain later why this test we needed to use. But firstly, we carried out the test, the experiment, to collect the data. It was a field-based technique. So once all the participants were down at the sports hall, we collected their shoe size. Once that was completed, we asked every participant to do a standing long jump, and then we collected that data as well, put it into a table, and due to having the data I needed, I can now show you how I found out like descriptions and statistics and some other things. So we'll swap to Edexcel now. So if we click up on data analysis, and we've got descriptive statistics already highlighted. So we come to this and get it back. That's the wrong one. So we highlight this, press enter. Okay. So this has made us have, we got a different one here. So we can see here from the data I've just changed then, we've got the mean here. So this is for shoe size, it was 8.0 and long jump was 2.0, so that was the mean. Come down to the medium, so the middle, as we like to say, so the middle shoe size was around about size 8, and how far people jumped was 2 meters roughly. The mode is the most common, remember, so the most common was say 10, and then the mode was again about 2 meters roughly jumping. Then you got your standard deviation here, and then you come down, we can see the range roughly. Okay, so next we are going to go back to our data here, and then we are going to do a graph so we can see it. So this is our graph. I'm just going to move it to a different sheet. I'm just going to move it to a different sheet so we have it separate. So here we go. So now we can just mess around with it a little bit. So title axis on. So this is your jump distance in meters. Down the bottom is what's the work. So shoe size, and then a title. What that is. Cool. So with this, then we can now also put in a line of best fit. So yeah, so we can see roughly where the anomalies come in and everything like that. So going back to our first sheet of data here, we're going to then calculate the number for the Pearson test to see if it was down to chance or if there's a relation significant. So we're going to put equals and start writing Pearson, and then we're going to highlight this part here, and then put a comma into it, and then highlight the long jump. And then we're going to close bracket and press enter. So this is our number. So with this we can then now go on to the book chapter, and I can show you if there is a significance. So you go on to this one here, so we had, where is it? We had 14 pupils. Take away 2 is 12, because this is to the degrees of freedom, so 12, and we're looking at this column here, so it says 0.5, 3, 2, 4, so ours was 0.59. Due to it being greater than that number, this means my data collection is significant. So yeah, so it's significant. So this means then I can now show you how I can. I'm just going to explain briefly, why we picked the Pearson test. So because it's interval data, so it's an inferential statistics and it's parametric data. So we come down to this one here, and then we go down here and it says Pearson. So carrying on from that, so we'll look at the type of data, and because we're in interval or ratio, but ours is interval, we come up here, and because we want to find out the relationship between the shoe size and the jump distance, come up to this arrow, and we did use 2 variables, so your shoe data and your long jump data. Therefore, this is why we use the Pearson test there. Okay, so now I'm going to go back to my PowerPoint and just explain the test. So the t-test, the t-test is a parametric test, and it tests for the differences. It can be used either interdependent testing or dependent testing, as I mentioned before. The test can only test 2 sets of data and is analysed through the mean of the 2 data sets. The variation of the data must be similar. Pearson test is tested for parametric, but it's for the relationship between them. This shouldn't be confused with the correlation values. A correlation shows the strength of a relationship. This is called the R value. So when I was on my Excel here, this is our R value right here, and you saw that it was significant. So the test again tests 2 sets of data sets and identifies whether the correlation is significant. The Mann-Whitney-U test for non-parametric equivalent, and it's equivalent to the independent t-test. This is required with ranked data or data that is not normal distribution. It tests for the significance of 2 independent groups, therefore testing the mean of 2 groups. The test will need 2 samples of the same size, allowing it to produce the U value, which is used to determine the level of significance. And lastly, the Spearman rank order correlation is a non-parametric. This is equivalent to the Pearson test. This should be used when the data that is ranked, and when it's ranked, therefore it should be used for ordinal data. The test is used to find the relationship between the 2 data sets. It uses the RS value to determine the significance of the relationship.